Hello, everyone, and thank you for being here today. I'm here to introduce you to Reflux, a transforming and adaptable material. And I'm standing on this stage by myself today, as most designers do. But actually, I'm not by myself. I'm part of an amazing team together with James and Benton and Pierre, who are supporting me in the audience today. So I started off my journey studying product design at Artes in the Netherlands, where I always felt a bit like the odd one out in a school full of designers. Being interested in that fuzzy space that exists at the intersection of design, science, and engineering, I decided to move to London to start a joint master degree program at the Royal College of Art and Imperial College. There, I met my boys, a group of other weirdos trying to escape the labels of their disciplines. Pierre, for instance, is a recovering electrical engineer, James, a mechanical engineer in transition, and Benton, a rehabilitated philosopher. But how do you orient a team of four radically different people with different backgrounds towards a common goal? Our starting point was to find a common vision or a shared philosophy from which we could build upon. And the initial question we asked ourselves was, why does technology seem to alienate us from nature? And how can we increase our relationship with nature by making technology perform more like natural systems? And a key term that stood out for us in this was adaptation. And this is because in nature, natural organisms and structures constantly adapt to changes in their environment. Take termites, for instance. The workers constantly reconfigure the tunnels in their mounds to regulate the flow of heat, oxygen, and moisture in their nest in response to changing weather conditions outside. And it is this ability of the termites that they can reconfigure their immediate surroundings that makes them so resilient to change. But by contrast, our built environment is static and isn't able to adapt. So how could we create objects that could adapt to changing conditions in the way that nature does? And to put this philosophy into practice, we adopted an experimental approach. And in our research, we came across a field called active matter, which is a branch of material science that seeks to make this vision of adaptive designs come to life. And at this point, it all seemed too easy. But our excitement was quickly tempered by a stark realization. We were not able to get a hold of these shape-shifting materials that we needed. And when we spoke to researchers that are specialized in this area, they all said a similar thing. These materials are expensive, hard to obtain, and complex to work with. But it was then that we spotted an opportunity. Why not try to make our own? So we scrambled to read as many scientific publications as we could to get a basic understanding of this field of shape memory materials. And when we started to understand the principles behind it, we started to collect researchers around us and try to recreate this effect. However, in doing so, we stumbled upon something unexpected. We actually found a new material quality that we didn't expect to find based on the papers that we read. And this led us to the development of Reflux. So Reflux is a shape-shifting material that is inspired by nature's ability to adapt. And to put it simply, it is a material that can change its shape and can move around in response to heat. So as you can see, it is a composite material that consists out of two parts. A colorful core that functions as a skeleton with a variable stiffness, and a transparent shell that is made out of an elastic skin. At room temperature, the core is rigid and you cannot change the shape of the material. However, when you heat it up to around 60 to 80 degrees Celsius with a hairdryer or some hot water, the core becomes soft and you can bend it and shape it in any way that you want. If you then cool it down in that shape, the core will harden again and it will stay in that shape. And then something really magical happens when you heat up the material again without touching it. It will automatically return back to the shape that we originally made it in. And that last part, that is called the shape memory effect, one that is caused by the mechanical interplay between the two materials. So as you can imagine, Reflux is incredibly fun to play with. And the more we experiment with the material, the more we learn about how it works and what it can do. And this really started leading us into looking at what could this material mean for us when we apply it in an everyday context. So there's a few key things that the material can do, which we have split into 3 main categories: reversible fixation, thermal actuation, and unlimited fitting. So Reflux has the capability to form a reversible fixation because if it's cold, it can provide rigidity and structure to external elements. And this fixation can easily be reversed again just with the application of heat. So to demonstrate this capability of the material, we developed an arm cast that can be easily applied, removed, and reused. So instead of discarding a plaster cast after a single use, this arm cast can be removed, disinfected, and used again by a different person. And to make the material more comfortable to the human skin, we can choose from a range of different material combinations that actuate at a different temperature, as well as heat the material up internally, so the skin is never in touch with high temperatures. Reflux can also act as a thermal actuator within a larger mechanism or system. And this is because when the material returns back to its original shape, it creates a force and movement. Imagine, for instance, having flat-pack furniture unfold itself just with the application of heat. And then finally, because the material has a variable stiffness, it can conform itself around different surfaces, taking or copying a shape while the material cools. To demonstrate this, we made a bicycle saddle that can be suited to fit the owner. And this can be done in a matter of minutes, providing comfort tailored specifically to the unique contours of your body. So Reflux can be used for many different applications. But to me, the most interesting thing about Reflux is how it answers the question we asked ourselves at the beginning of our journey. By looking at how organisms and natural structures constantly adapt to changes in their environment, we too can develop technologies that can help us adapt to changes in our lives without generating dangerous amounts of waste. So Reflux can help us to replace static objects for products that are adaptable to different people and different situations, and that can be reused again to extend the lifetime of these objects. In a culture with disposability at odds and a pressing environmental crisis, we need to rethink how we use materials to fulfill our needs. And in tackling our approach to rapid consumption, we need to consider solutions that do not only involve the creation of new materials, but how these materials function within a larger system. It is not just about what materials we use, but also about our associated behaviors with their use. So with Reflux, we imagine a world in which the materials we use are no longer inert, allowing objects to be reshaped by users according to their needs. And as a multidisciplinary team, we really believe in the power of collaboration to bring together science, design, and engineering. And by exploring this negative space that lies at the intersection of these fields, we can provide innovative answers to complex questions and translate cutting-edge research into everyday applications. I finally want to warmly invite you to come to the Veemgebouw to meet my other teammates and to see more of the world of Reflux. We've made some samples for you to play with, and would really love to hear from you how you want to reshape the world around you. Thank you very much.